Second half of section 4.5, I didn't want it to get too long for you. We worked on angle, side angle, no, side angle, side. Now we'll be working on the HL theorem. I feel like this is crooked. Let me see if I can straighten you out, or maybe I'm crooked. Cheat sheet 6 again. Taking a look at cheat sheet 6, already did side angle, side. Here's the HL, short for hypotenuse leg. If the hypotenuse and a leg of the right triangle. So first of all, it has to be a right triangle. Of course, if it doesn't have if it's not a right triangle, a hypotenuse doesn't even exist. Are congruent to the hypotenuse and a leg of the second triangle, then the two triangles are congruent. So I did allow a diagram on this cheat sheet. Normally I'd only have words, but here's a small diagram. The three things that you have to have a right angle on both triangles, otherwise they're not right triangles. Absolutely have to have the hypotenuse on both triangles. But then notice it says, and a leg. So in this diagram, it shows to have these as the legs. But it's not wrong, and you will see it often, that instead of those two legs, they'll have the bottom or the base two legs with the hypotenuse. It doesn't have to be these. I knew that. They were all going to move. So it could be the hypotenuse and the bottom legs or the hypotenuse and the side legs, as long as it's a leg and a hypotenuse. So in looking at an example problem, is it possible to prove triangle MNO, this triangle over here, MNO, is it possible to prove that it's congruent to triangle RON? We like to call him Ron. So we're taking these two triangles, and of the three things we need a right angle, a hypotenuse, and a leg. Taking a look, we definitely have the right angles, so good, it's a right triangle. Hypotenuse, reminder, the hypotenuse is always the long side, the diagonal side, the side across from the right angle, however you want to describe it, this is the hypotenuse. And RN is definitely the hypotenuse, and so is MO. Looks like they put it in the right order. MO, RN, correct order. So we have the right angle, we have the hypotenuse, but now we need a leg. Let me put it back to where it belongs. This is what your diagram looks like. We need a leg of each triangle, and once again, believe it or not, segment ON is congruent, however you want to put it. If you want to put segment ON again, it's okay, but segment NO is acceptable also, by the reflexive property. Because we now have a right triangle with a hypotenuse and a leg, then yes, they are congruent by HL. Don't make this any more complicated than it is. You're looking at your cheat sheet, you're using your cheat sheet. How do you abbreviate hypotenuse leg theorem? Just HL, not HLT. Hypotenuse leg is just hypotenuse leg. Next one. Is it possible to prove triangle JRM is congruent to triangle JTM? It looks like I'm missing an R. Put an R in there for me. Is it possible to prove that they are congruent? Well, we have a right angle on triangle JRM, and since this is a straight line, if this side is a right angle, this is automatically a right angle. And if we have two right angles, then we have two right triangles. So check, we've got right triangles. We also can make a leg of the triangle because we see that segment JR is congruent to segment JR by the reflexive property. However, the hypotenuses are not labeled. You could stand back and look at them and be like, they look congruent to me. That's got to be an isosceles triangle. Not unless you're told. If you're not told that that's an isosceles triangle, that's not an isosceles triangle. You know nothing about the hypotenuse here and here. We have a right angle and we have a leg, but not a hypotenuse. So that one's a no. That's it. Nice, short, abbreviated notes, but I didn't want it to get to be too much with the two different versions. So good luck. Keep up. Keep doing your assignment. We now have SSS SAS, and HL. We still have 2 more to go with ASA and AAS. So focus on these and get them right.